Empirical formulas are the only new thing that we're learning this unit. Empirical formula means the simplest ratio of the elements in a compound. So if I have 3 compounds here, formaldehyde, acetic acid, and glucose, which one has the simplest ratio of the elements? Formaldehyde. How do you know that?
Has the least amount of...
Think of math terms. It's the most simple, the most simplified, the most reduced. Exactly. Do you know what formaldehyde is? Biology, life science, middle school. Did you dissect anything? That stinky stuff that they preserve things in? This is formaldehyde. Here's its formula. Do you know what acetic acid is? It's in your cupboard at home. You know what it is? You thought you know what it is? Vinegar. Good. Similar characteristics? Kind of. Maybe in the way they smell a little bit. And glucose, what's that?
It's like
sugar. So, stinky preservative, vinegar, sugar. They all have the exact same elements in the exact same order with the exact same ratios, but talk to me about their properties. Totally different. So, this we can see visually. There's something called a multiplier. What's the multiplier between formaldehyde and acetic acid? Acetic acid looks to be 2 times what formaldehyde is. And glucose looks to be 6 times as big. Can you see the multiplier? Yes, visually we can see it. Sometimes you can't see it, and this is our formula of how we're going to figure it out. If we took the mass of each of these, let's say formaldehyde and sugar, the molecular mass, this one would be the sugar, glucose. If we added up all these guys, got its mass, and we divided it by the mass of the empirical formula. What's empirical? The simplest one, which is formaldehyde. If we took the mass of formaldehyde, guess what number we would get? The 6th. Okay? So sometimes if you can't see it based on a formula, if you calculate the mass of the big one over the mass of the simple one, you'll get the multiplier. It'll tell you how much bigger it is. Okay? I have 3 examples for you. We're going to do step by step. Calculating the empirical formula of a compound that has barium, sulfur, and oxygen. Step 1. Assume that you have 100 grams of your substance. Why? If I have 100 grams, what can I do to these percentages?
Put them on a filter.
Make them in? To grams. My percentages just change into grams. Easy enough so far? Step 2. No, this would be 3. Step 3. Convert all of your grams into moles. How do I do that? Grams into moles. I divide by the mass. If I have this many grams of barium, what would be my mass of barium? be a 137.33. Someone punch that in the calculator for me. 137.33. 0.42. 0.428. Okay. We're good. Sulfur. How do I convert sulfur to moles? Sulfur is 32.07. .42. Huh. That looks familiar. And oxygen. Oxygen's mass is 16. You're guessing 0.428? Only when it's by itself. 1.7.
Those percents next to each
One.
element just didn't,
These are the percent abundances. 1.72, it rounds. Okay?
what they stand for again?
The percent of abundance?
Their abundance.
Yeah, that's abundance. Are we okay through step 3? Step 4. Divide by the smallest. To get a ratio. Which is my smallest number of moles? 0.428? Divide them all by 0.428. Obviously, the first one's going to be 1, and the second one's going to be 1, if you need a calculator for the last one. 4.0. We're going to call that 4. Divide by the smallest. Divide by the smallest. 0.4 is smaller than 1.7. Divide by the smallest. That gives me my ratio. That means how many bariums do I have? 1. Do I put a 1 here? Typically not. How many sulfurs do I have? 1. How many O's do I have? 4. So guess what my formula is? So we're like going backwards. As long as you've got the steps down, you're good to go.
Wait, is that 1.72?
1.72, yeah, it rounded up. Did you write down the 4 steps?
Wait, I didn't write down.
There's technically a 5th step. We'll get to it in a second. So leave space for number 5. That's the last one. Or we can talk about it now. 5th step is multiply by a factor. Your factors are either going to be 2, 3, or 4, so that you get a whole number. So if when we calculated these ratios over here, what if I got a 1.5? Can I put a 1.5 in my formula? No. If you get a 1.5, which factor do you think you'd multiply by to get them all to be even? 2. So you would multiply them all by 2, so you get a whole number. What would the ending have to be if you multiply by 3? What's a third? 0.3 repeating. So 0.33, something around there. And what do you think the ending would be if you'd have to multiply by 4? 0.25 or 0.75. If you want to write yourself a little cheat sheet, your factor 2 is when things end in 0.5. Your factor of 3 is when something ends in 0.33. And the factor of 4, 0.25 or 0.75.
What if it's like 4 or 5?
Then I would use this. It might be just a sig fig, whatever it's closest to. If it's 0.32 or 0.34, multiply it by 3, whichever one it's closest to.
So we multiply it all by 2.
Multiply them all by 2. We're going to get to one of those examples in a second. We're not there yet. Here's this multiplier stuff. I'm giving you the empirical formula. This is the most reduced. How do I know? Thinking about math. 2 and 5. Can they divide by the same thing? No. So it has to be the most reduced. If the molar mass is 284, what's the molecular formula? We have to go back to this multiplier stuff. The molecular mass divided by the empirical mass gives me my multiplier. Molecular mass divided by empirical mass equals multiplier. What am I given? 284 goes where? Top or bottom? Top. 284 grams divided by, how do I calculate the mass of the empirical? Two times, what's phosphorus? Is your periodic table out? 30.97? Yeah, let's go 31. These are whole numbers down here. Simplify. 2 times 31 plus 5 times 16. What's the mass of my empirical? You have your calculator. 142?
Yeah.
Grams per mole. So, 284 divided by 142. We don't even need our calculator for that. What can we see? What's the multiplier? It's 2. So that means the molecular formula is 2 times as big as the empirical. So what would my molecular formula be? P4? O10. The empirical formula is the most reduced, 2 and 5. The molecular is the bigger one, the not reduced one, 4 and 10. 4 and 10, you divide by 2, you can reduce down to the empirical. It'll always be, yeah, if you're what if my multiplier was 3? Then it'd be P6O15. Simple enough? One more practice. What are the empirical and molecular formulas of a compound which contains 40% carbon, 4% hydrogen, and 54% oxygen? Step 1, what do? Turn it into grams. Done. Step 2, what do? Just change it. Grams to moles. Oxygen. Oxygen, 3.41. Hydrogen? 4.52. And carbon? 3.40. Now that we've calculated all of our moles, the next step is to divide by the smallest. My smallest number here is 3.40, so I'm dividing them all by 3.40. Again, the first one is obviously 1. The last one is obviously 1. The hydrogen, if you punch that in your calculator, you get 1.3. So this is when we have to look at step 5, and we have to multiply by a factor. The factor that would change all of these numbers into whole numbers is 3. So carbon, my ratio was 1. 1 times 3 equals 3. For hydrogen, if you take 1.3 and you multiply it by 3, you get 4. And then for oxygen, again, multiplying them all by 3, I get 3. This is my empirical formula. How do I know it's my empirical formula? Can you reduce 3 and 4 any further? No. So the second part of this question asks for a molecular formula. When it asks me for a molecular formula, that's when I need my multiplier. Multiplier, again, equals molecular mass over empirical mass. Given in part B of this problem is my molecular mass. Multiplier equals molecular mass, or 264 grams per mole, over my empirical mass. How do I calculate the mass of my empirical formula? I need to take 3 carbons, or 3 times 12. Again, let's simplify things and just keep them whole numbers, since this mass is given to us as a whole number, plus 4 hydrogens. We'll say hydrogen has a mass of 1, plus 3 oxygen, which has a mass of 16. 3 times 12 plus 4 plus 3 times 16, my empirical mass is only 88 grams per mole. Figuring out my multiplier, 264, my molecular mass, divided by 88 grams per mole. 264 divided by 88, I get a multiplier of 3. That means my molecular compound is 3 times as big as my empirical. If this was my empirical, 3 times that would be C9H12O, not 3. 3 times 3, or 9. So your molecular formula is always larger, the not reduced version, of your empirical formula, which is the most simplified version of the compound.